Welcome back to the course. In this part, we are going to take a look how we can create procedural animations using VEX. I know that writing code and coding can be very intimidating in the beginning. It was the same for me before I started using Houdini. The only code that I was able to write were some expressions in After Effects, and that's really it. And I'm still not a coder. I still can't use VEX really creatively. You know, I can create basic attributes, do some very basic things, but I'm not really into it. And I also don't want to give you a full introduction on VEX because this would take its own course. But I want to include it in this basic course just that you see that it is a part of Houdini. And if you really want to work in Houdini and learn it, then I would recommend that you also start using and learning VEX because it's a very, very powerful and handy part of Houdini. We will try to keep it as simple as possible. So let's take a look what VEX actually really is. I already told you that when we set up our VOPs here, that we actually create code with these nodes. So this is visual programming, and you can actually take a look at this code by right-clicking on your VOP node and then choosing this VEX VOP option and then choose View VEX Code. At the first sight, this looks very complicated, and that has to do because Houdini is just setting up a lot of different parameters and attributes here. But if we scroll down here and really take a look at the code, and that's this part here, and if we enter now our VOP, this is actually not so complicated. So what you see here, it is creating a value and setting it to 0.02. That's exactly what this constant here is doing. The constant name is value. If I change this now to, let's say, my value, and now we have to right-click this again because otherwise it won't update, and scroll down. But now you say that here, this is exactly what we are doing. So these things are, of course, connected. Then the next step here is this multiply node, and you can see the code here. So it creates a product. That's the result here, product. And this is time times ptnum times my value. That's exactly what we are doing here. Then the next node here creates this line of code. It takes the sign, and here's the sign function, and it takes it from our product. So from this one here. And then we are setting a vector with this vector set. So it creates a new vector, uses this function here, the set component, and then just sets our middle value here to the sign. So this is the code that is created, and you can take a look at it, and then it is assigning it to the new position value. So you are already coding when using a VOP. Now let's take a look how we can do this with written code. And therefore we need a wrangle. So let's add in a wrangle. With wrangles, it's exactly the same as with the VOPs. You have all these different things, but these are actually more or less all the same except the volume wrangles. But all of these wrangles like detail, point, primitive, and vertex are the same, and attribute wrangle also, they are just set up differently. So let's use this point wrangle. Let's put it in, and you see that this is just set to run over the points. This also does the same as the VOP. It applies all the calculations that you put in here in code form over all the points that you feed into this node. So let's do that. Let's feed our points into here, and let's then connect it to our switch and switch over to the result of our wrangle. So I will just rename this to sign because that's what I actually want to do here. And now let's take a look how we can write code in Houdini. I will open up a separate window by pressing Alt-E, and this will just open up a separate window that we can see a little bit better what we are actually doing. Now again, let's go over a few simple examples. If we want to change our position with code, we have to access somehow our attribute. And whenever you want to access an attribute, you have to type the @. And @p is our position attribute. Now we can say equals, and now we could change this, for example, by adding a value. So let's again use @p and then use plus, and then let's say 10. On the end of each command, on each line, you want to put in the semicolon. And now if I click apply, you see that this is copied over here, and suddenly all our points are gone. And that's because I shifted them for 10 units on X, Y, and the set value, as you can see here. So now all of these values are updated. And you can also see this in the geometry spreadsheet, of course. Now, there is another option to do that, and the simpler option, if you want to add a value to the component itself, instead of writing it like this, and let me just turn this off by putting in 2 slashes, this will just turn off a command. You can do the same by writing add p and then plus equals, and then we can put in 10 here. And this apply has exactly the same result as you can see here. If I set this now to 5, of course, these will jump down, apply, and you see now we are manipulating the position with this value. If you only want to change the y position, it's pretty simple. You just come in here, and instead of applying it to all the values, you put in .y here and apply. And you see now we are just changing the y height here of these, the y position, as you can see now. So how can we add in our sine motion in VEX? And therefore we need a function. So if you want to add in a function, we can type in the name here, and the name for sine is just sin. And then if I open brackets, Houdini realizes that I'm using a function, and if it knows the function, then it will react. And you see here now we have all the sine options, and the sine just requires a value, and we can just use the value 1 for a moment and then put this in and apply, and you will see the points now get shifted with our sine function. If I put in now, as we did it before in our VOP, the add time attribute by just typing in add and then capital T and IME time and accept, now if we play this, it will do exactly the same as in our VOP before. We are changing the position of all points according to the sine of our current time value. Now, if you want to speed this up, again, we can just multiply this by a value. So let's apply this, and now we can see the result, and you see this is now just moving faster up and down. So that's exactly the same as we did before in our VOP. Now, of course, we can again also put in our point number, and to do that, we have to access add pt_num. That's the name of the point number. Apply, and now we have a very similar result than we had this before. Now, to make this slower, again, we can put in time 0.002. That's exactly the same as we did before in our VOP. And now we should have a very similar result here, as you can see. So with this one line of code, we are creating exactly the same result as here in our VOP. That's really giving us exactly the same result. And if we change the constant here now to 0.02, as we did here in the end, and apply this, now we have exactly the same result. So let's turn this off for a moment. Let's go out here and let's compare these two. So let's run this for a moment. And now on frame 49, we can switch over to our VOP. And you see it is exactly the same. So this line of code here creates the same as this setup of visual programming nodes. Now let's take a look how we can do the same with the noise, and let's add in an attribute wrinkle again and put it in here. After this one, let's deactivate this one, let's deactivate this one and activate this one over here. Let's make sure that our switch is set to 2. Yeah, it is. So here we are. This is our sine, this is our noise. Let's just rename this. I will do this later. I will organize this for you, of course. And now let's run this over points. That is important. And let's press Alt-E to open up the separate window so that we see what we are doing here. So in this case, I want to create a variable. And the difference between variable and attributes is an attributes will be saved somewhere. So if I create an attribute, I can use this like, for example, I want to create a float attribute, f_at, and that is called my result as before. And then I could give it a value equals 10 and apply this. You will see that now I have my result here stored on my points because we run over points, and I can see the result here on my geometry spreadsheet. That's how you create attribute with VEX. So it's very easy to create basic attributes in VEX. If you want to create a vector, then you would have to put a V here, and then you have to add in a bracket here, and of course set 3 components. If we want to create a vector 3, and again, close the brackets and then apply. And you see that this will now add in my result as a vector here. So that's just a very small side info how you can create attributes in VEX. And the other thing beside attributes is variables. And variables are not stored on any points. They are only used inside your code. So in this case, I want to create a float variable, a float value that is called noise. And I will just choose this name. So this is a custom name. And now I want to use a noise function. So type in noise and then open up a bracket. And let's close this bracket for a moment and let's put a semicolon in. If you want to have more information about a function, you can move with your cursor inside the word here and then press F1 on your keyboard. This will open up the Houdini documentation. So again, this is one of the great functions of Houdini, that you can directly go to the noise function info now, and you can do this of course with every function. And now you can see some options. And if you want to learn VEX, I would really recommend that you also learn how to read these instructions, because if you know how to use this, it will make your life way easier. So there are always a few different options how you can use these functions. And you see that it requires some kind of a position value. It is a float value that it requires, but you can also use it with a vector. So you can also use add p, for example, and that's what we will do. So we will use a position vector in this case. So let's just type in here add p. We want to use our position and apply that. And right now it is not doing anything. It is just creating a variable, but this has no influence on our position. But if we now come down here and say add p.y plus equals, and then we type in our variable name and close it with a semicolon and apply, then you see suddenly something is happening. Now we're changing the position of our points using this noise function. You see that the amplitude of this noise is quite small, but if we want to increase this, we can just multiply the whole thing here with a value. So this is something like the amplitude. If we multiply it times 4, then you see that we actually get a bigger amplitude now. And if we want to change the frequency, we can multiply our position. So if we multiply this, for example, with a value of 0.1 and apply, then you see we change the frequency of this noise. So you can just think of this as the frequency by multiplying the position, and this will change the size of the noise. Now we have the same frequency as we used in our VOP and a very similar amplitude. If we want to animate this now, we could create an animated vector. We can do this directly inside our code here, but let me actually create another variable because this is a bit easier. I want to create a vector this time. So let's take a look how we can do this. We just type vector. And then we call this our offset, because this is exactly the same as the offset value in the VOP node. So let's add this in, and the offset is a vector. And to set a vector, we use the set function. And now we can type in our vector. So for example, if I now type in here a value of 10 and 0 and 0, and just add this now, this offset value to our position. So we can say plus offset and apply. You will see that now our noise got offset. So that's exactly the same as changing the offset in the VOP, the offset value in the VOP. Now we only have to change or animate this value here. So instead of doing it on the x-axis here, let's do it on the y-axis. That's the same as we did before. So we can just put in here now, add time. And now if we hit apply, we will have an animation, because now we have a time-dependent attribute in here. And you see now we're actually creating a procedural animation here. So if you want to change the speed, you can just multiply the time, maybe times 2 to make it faster, and apply. And you see now we have a faster animation. So this is how you can create the exactly same thing. And let's take a look at that again here. So you see here we have the VOP, and we really do pretty much exactly the same thing. So we are creating a noise value, that's this node here, and here we have this function, that's this here. Then we are changing its frequency here. This is built into this noise node, but we can do this by just using the position and multiplying it by 0.3. we are changing the offset here. And in this case, we are changing the offset with multiplying the time with a constant and setting it to our second component on the y. That's exactly what we do here, is this operation. And then we are just adding this to py. And you see that this is way simpler in our VEX code than it is here. Here we had to add in all these vector float and stuff, or the alternative is to use the vector set component node. And yeah, we get exactly the same result. So if you like the VEX workflow, if you prefer it over the VOP, then I want to give you a recommendation where you can get started with VEX. A very cool website, actually, and that is CG Wiki. I will just take a look at it where I have it. Yeah, here I have it. It is talkaroo.com CG Wiki Joy of VEX. The Joy of VEX is a program that really teaches you the basics of VEX in a very nice way. So I didn't make it through the whole program, to be honest, but I started out with that, and it explains how to create some different attributes. And yeah, that's what I can recommend. So this is it with this part. Thank you very much for watching. In the next part, we're going to take a look at procedural modeling, and we're going to start building our final project.